So here we have some functions that I've graphed. And I want to talk about extreme values. Another fancy word is extrema. So I'm going to look at each example and discuss what the absolute extreme values are and the local extreme values, if they have any. So here we have a function that is linear. And you can see because it goes forever down and up in opposite directions, it's not going to have a maximum or a minimum value. So in this case, there are none. Now here, this is interesting. This is also a linear function. It's constant. And it's the function f of x equals -2. So since it's constant, the maximum value is -2 and the minimum value is -2. And that maximum and minimum, maximum and minimum values occur everywhere. So that's the interesting case here. So we would say the absolute maximum and the absolute minimum both are -2. Here we have a quadratic function. By the way, I should interject. We say that when we give the maximum or minimum values, we're always giving y values. Where they occur is given to us by an x value. So here they occur everywhere. That's because the x coordinate for all these points is part of the function. And the domain is all real numbers, but every one of those points gives an output of -2. So the minimum and maximum value of -2 occur everywhere. And those, when we say everywhere, we're talking about all the different possible x values. The actual maximum or minimum value is -2, which is a y value. So it's very important to clarify that. Here, we have a maximum value, and it's an absolute maximum, and it occurs at -3. So this point is -3, and this is 4. So the maximum value is 4, and it occurs at -3. Again, the value is the y value, and where it occurs is the x value. Here we have an absolute maximum, and it's at -1 and 1, and the value of the absolute maximum is 2. So the absolute maximum is 2, and it's located at -1 and 1. So it's located at 2 places, here and here. The value is 2, it's located at the x value is -1 and 1. Now this is not a minimum, not an absolute minimum, because as you can see on the left and right here, the function goes even lower forever. So there is no absolute minimum. But we say here, this is a local minimum. In other words, if you just focus on this locality here, this point would be the lowest around that point. So the local minimum value is 0 because it's sitting on the x-axis, and the height is for y equals 0. So the local minimum value is 0, and it occurs at 0. So the x, so it's at the origin. This is the x and this is the y. All right, looking here, we have no absolute maximum or minimum. So no absolute max or min, because the function goes down forever and up forever, but here we have two local extreme values. This is the local maximum here. The local max is 0 because it's sitting on the x-axis. It is 0 and it occurs at -2. So that is the x value, is gives me the where. That's why I say at -2. So it's a local maximum value is 0 at -2. And here, the local minimum is -3 at 1, x equals 1. And then finally here, we have the square root function. This is f of x equals the square root of x. The the absolute minimum occurs at the origin. So absolute minimum of 0 at x equals 0. And it has no absolute max or min. I'm sorry, it has no absolute maximum because it doesn't look like it looks like it's leveling off, but it does go up forever. So no absolute maximum, but a minimum here. And that, I hope these examples help you understand what it means to be an absolute extreme value or a local extreme value. And another term for local is relative.